do some multiplying. So all the properties that we talked about, and these properties are actually on page 23 in your book, top of page 23, so you can see them a little bit better. All of these properties actually also apply to addition, except for your zero. Obviously, multiplying by zero doesn't apply. But commutative property, order. Remember with addition, 2 plus 3 is 3 plus 2. The same is true with multiplication. 3 times 5 is the example they give you. 3 times 5 equals 5 times 3. So as long as it's all multiplication, your order doesn't really matter. All right? Associative. If it's all multiplication, you can group it however you want it. 2 times 5 times 3 is 2 times 5 times 3. I mean, it doesn't matter what order you get those answers in. It's going to be the same answer. Identity property. Remember, in addition, if you add 0, it doesn't change the identity. In multiplication, if you multiply by 1, it does not change the identity. Distributive, we've already talked about. If you have a multiplication outside of a group, you can distribute that multiplication through. And zero property, if you multiply anything by 0, you get 0. All right, and this will come into play when we start doing some solving. All right, so those are just properties that you can apply when you start doing multiplication. Flip to page 24. All right, let's look at these rules of multiplying. All right. If factors are either both positive or both negative, the product is positive. So if your factors are both positive or both negative, then your answer is going to be positive. And so the other rule then is if one of them is negative and one is positive, then your answer will be negative. All right. So if you multiply two numbers with the same sign, you're going to get positive. If you multiply two numbers with a different sign, you will get negative. All right. So same sign is positive, different signs are negative. You don't have to worry about which is bigger like you do in addition. So the first one's very simple, this example. 2 times 9. What is 2 times 9? 18. And I have one positive and one negative. So what is my answer? Negative. And I am done. B, 4 times 6 is what? 24. I have a negative and a negative. So what is my answer? Positive. Very simple. So then you start developing these other rules. Let's say you're multiplying more than two numbers. Two numbers is easy. Same sign positive, different sign negative. When you start doing more than two numbers, then you count how many negatives you have. If you have an odd number of negatives, your answer is going to be negative. If you have an even number of negatives, your answer is going to be positive. So you could have 12 numbers, and if they were all multiplication, you could just add up your negatives and already decide what your answer is going to be and not worry about it. All right? So let's look at the first one. How many negatives do I have in this? 3. So I automatically know that my answer is going to be negative. And now all I have to worry about is the numbers, right? 2 times 3 is? Times 5 is? 30. And negative 30 is my answer. So you can decide up front if your answer is going to be positive or negative. And that's really a good idea because a lot of times I think you know that it's going to be negative and you just forgot to put your negative down or you questioned yourself. Look at this B. How many negatives do I have?
2.
So is my answer going to be positive or negative? Positive. It's going to be positive. 4 times 3 times 1 is 12. So my answer is 12. All right, let's go over these. Number 2, how many negatives do I have? None. So this is positive 56. What about 6? How many negatives do I have? So this is going to be negative 21. 10, how many negatives do I have? This is going to be negative 632. All right. Examples 4 and 5. Fractions. Multiplying fractions is actually really simple. The rule is just multiply across. So you don't have to have a common denominator to multiply fractions. You literally just multiply straight across. And so the question is, can you cross cancel? Cross canceling is just another way to reduce. It's reducing ahead of time, okay? And so cross canceling means that you can cancel any numerator to any denominator if you are multiplying, whether it's straight up and down and you can reduce or diagonally you can reduce. You can reduce any numerator to any denominator if you are multiplying fractions. And so you can reduce up front like that, which makes it a little bit smaller numbers to deal with, or you can reduce at the end. But either way, you need to reduce if it's possible. So for this example that they gave us, we have a 3 and a 7 on top and a 4 and an 8 on bottom. So they did not give us an example that we could reduce ahead of time, right? The 3 cannot reduce with the 4 or the 8, and the 7 cannot reduce with the 8 or the 4. So in this case, we're just going to multiply across. Now, your rules of negatives and positives work the same. How many negatives do I have in this problem right here? 2. So is my answer going to be positive or negative? Positive. All right. So we are just going to multiply straight across. I know my answer is positive. So 3 times 7 is what? 21. And then I'm going to multiply 4 times 8, which is what? 32. All right. 3 times 7 and 4 times 8. And if you could not cancel at the beginning, you won't be able to cancel at the end, right? I mean, if the factors didn't reduce before, they're not going to reduce now. So 21 over 32 is your answer there. All right, let's look at mixed numbers here. They gave us one mixed number, and then they gave us one that's reducible. All right, when you're multiplying mixed numbers, you really want to change them to improper fractions. Basically, a mixed number is adding the whole number in the fraction. So what you're doing here is you are multiplying two binomials. You're multiplying two groups of parentheses here. And you're going to mess up if you try to multiply it as mixed numbers. There's a way to do it, but it's way more difficult than just making it an improper fraction. So let's first remember, how do I change a mixed number to an improper fraction? What do I do? Anybody? Around. So I'm going to say 5 times 2 plus 1. All right, we're just going to make a little loop. When you have 2 and 1/5, we're going to multiply here and add there and just go around. 5 times 2 is, plus 1 is 11. And so we're going to change that to 11/5 and do the same thing with this. 7 times 4 is 28, plus 2 is 30 over 7. All right, and so now we can multiply, and here we can actually cross cancel. So first, I have two positives. My answer is going to be positive or negative? Positive. And then remember, any numerator can reduce with any denominator, okay? So the 11 and the 5 or the 11 and the 7 cannot reduce, right? Those are actually all primes. However, my 30 can reduce. It cannot reduce with the 7, but it can reduce with the 5, all right? How can I reduce it? What goes into both 5 and 30? 5. So I'm going to divide both of those by 5. 5 divided by 5 is 30 divided by 5 is 6. And now I can just multiply straight across. 11 times 6 is 66. And 1 times 7 is 7. 66 over 7 is your answer. You can change it to a mixed number if you want to, but you can leave it like that. That is reduced as much as it will go. All right? So 66 over 7. All right, let's look at B. B is already improper fractions or, reduced fractions. But I can reduce this one before I multiply as well. 3 will not reduce with 4. 3 will not reduce with 7. But 18 will reduce with 4, right? What goes into both 18 and 4? 2, all right? So 4 divided by 2 is 2. 18 divided by 2 is 9. So I have negative 3 over 2 times 9 over 7. And now I can just multiply straight across. Now I have one positive and one negative. So is my answer going to be positive or negative? Negative. 3 times 9 is 27. 2 times 7 is 14. And that is my answer. All right, so I want to talk really quickly about converting. You don't do a ton of conversions in here. When you get to a little bit higher math, there's a lot of conversions, and then definitely in your sciences, you do some conversions, okay? And conversions are just multiplying by fractions. That's legitimately all you're doing when you convert things. And so it says, I want to convert 51 inches into feet. So I always start with 51 over 1. I'm just going to put it as a fraction. And then I'm going to look at my inches, all right? How many inches are in a foot?
12.
Yeah, there's 12 inches in a foot. Anytime you're converting, you're trying to cross cancel, all right? So if my inches is on top and I'm trying to get rid of inches, it must go on bottom for me to be able to cross cancel it. Because if I put it on top, I'm going to have inches times inches, which is actually inches squared. And I don't want inches squared. I want feet, okay? So I need to put my inches on bottom and my feet on top. And you said there's 12 inches in 1 foot. So I'm going to say 12 inches in 1 foot. All right. And now I can see that I'll be able to cross cancel my inches. All right. Because that's the unit that I'm trying to get rid of. And so you can cross cancel them. I can cancel out my inches and my inches. Right. And now I can just multiply across. 51 times 1 is 51. 1 times 12 is 12, and I have feet. Now I will say, with unit measure, you don't want to leave it as an improper fraction. Like if you walked into Lowe's and said, hey, I want 51/12 feet of wood, they would look at you like you were crazy, all right? Because that's just a weird way to give a measurement of like a 2x4, okay? So you want to actually put this into some sort of form that you could say it, that it sounds normal. So you're going to make this a mixed number. So 12 goes into 51 how many times? 4, right? And how much is left over? 3/12, which I want to reduce, right? To 1/4. So if I said I want 4 1/4 foot of wood, that sounds a little bit more easy to measure out, right? So conversions are literally just multiplication of fractions. That's all it is. And there's some conversions you should know. Like you should know how many inches are in a feet, right? You should know how many feet are in a yard. You should know how many feet are in a mile. How many feet are in a mile? Now let's go over these. Could I cross cancel here? Yes, what could I cross cancel? 6 divided by 6, 18 divided by 6. Negative and a negative, so my answer should have been positive. Positive 3/19 when you multiply across, okay? All right, for this one I need to convert, so I have negative 3/7, and then what does 5 3/5 convert to as an improper fraction? 28/5. Can I reduce here?
Yes.
Yeah, what can reduce? My 7 and my 28. Positive and negative, so my answer is going to be negative 12/5 was my answer. So dividing real numbers basically works the same as far as your positives and negatives go. We're on page 28. If you have an odd number of negatives in your division, different signs, it's going to be negative. If you have even number or the same sign, it's going to be positive, all right? And so you're going to do your same rules. You just have to remember your division. So 14 divided by 2, they're both positive. My answer will be positive. You will get 7 here, right? 7. It can be written like this with a division symbol. 14, your division symbol, and 2. It can also be written like this with a fraction line. Fraction is just another way to write division. It is a ratio between the two numbers. So this means negative 72 divided by positive 9. Is my answer going to be positive or negative? Negative. And 72 divided by 9 is 8. And so these are the rules for division. Let's talk about the term reciprocals. Reciprocals, also called multiplicative inverse. A reciprocal is really just the flip of the number. When you multiply reciprocals, you get 1. So an example would be 3, and the reciprocal would be 1/3. And if I multiply 3 times 1/3, remember 3/1, I am going to get 3/3, which is 1. That will always happen with reciprocals. So reciprocals just mean flip. It's multiplicative inverse. And you use this when you are dividing fractions. So when you're dividing fractions, the definition of division is technically multiplication by the reciprocal of the divisor. That's the guy you're dividing by, okay? So division is just multiplication by the reciprocal, all right? You'll use this when you solve equations as well. And so if you look at example 2 here, says 4/5 divided by 9/10. The little memory game that you learn when you first learn to divide fractions is keep, change, flip, right? Hopefully you've heard that. So you keep the first one the same. I'm going to keep that 4/5. Change. I am going to change this from division to multiplication. And then flip. I am going to flip my divisor or my second one, which is 10/9. Keep, change, flip. And then I can apply my rules of multiplication. Can I cross cancel here? Yes. I can cancel this. It's a 1 and a 2. And then I'm going to multiply across. 4 times 2 is 8. 1 times 9 is 9. All right, look at the next one. Keep, change, flip. Keep this -5/7. Change division to multiplication. How do I flip a -5? How do I flip that? I put a 1 over it. -1 over 5. Remember, -5 is -5 over 1. So to flip it is -1 over 5. I can cross cancel the 5 and the 5. It is negative times a negative. What is my answer going to be? Positive. So 1 times 1 is 1. 7 times 1 is 7. When I have a mixed number, what do you think I want to do with this first?
Unsimplified fraction.
Yeah, I want to put it in fraction form, not mixed number. All right, and so I definitely don't want to leave it like this when I'm dividing. 12 times 1 plus 7, right? And then so leave it as division right now, just so you can see what's going on. Obviously, you can do it faster than this when you're getting to it. But 5 times 7 is what? Plus 3?
38.
Yep, 38 over 5. All right, and so now I have improper fractions, and now I can do my keep, change, flip. Keep the first one. Change to multiplication. Flip the second one. All right. And can I reduce this one?
Yeah.
What can I reduce?
19.
Yeah, I can reduce the 19 and the 38. All right, and then multiply across. I have a negative times a positive. Is my answer positive or negative? It is negative, right? 1 times 5 is 5. 12 times 2 is 24. All right. Questions on those three. Questions on those three. All right. So this is how you normally see it. You will see a fraction divided by a fraction. Keep, change, flip. Keep the first one, change it to multiplication, flip the second one, okay? Sometimes you'll see it as what's called a complex fraction. A complex fraction. This is a fraction over a fraction, all right? But what does that fraction line in the middle mean? Division. It just means division, right? So this is the same thing as saying 4/5 divided by -1/2. You can still keep, change, flip. All right, because what happens is you're just flipping the denominator up. So I'm going to keep the top 4/5. I'm going to change this to multiplication, and I'm going to flip the bottom. So I'm going to change the bottom to -2 over 1. And now I just have a straight multiplication problem. 4 times 2 is 8. 5 times 1 is 5. It was 1 positive and 1 negative. What is my answer? Negative. And the same holds true of B. The top, I'm going to keep the top 2/3. I'm going to change this to multiplication. And I'm going to flip the bottom. The bottom is 4. How do I flip a 4? 1 over it. Now for this one, can I cross cancel? I can. My 2 and my 4. This is a positive times a positive. What's my answer going to be?
1/6.
Yeah, it's going to be positive. 1 times 1 is 1. 3 times 2 is 6. So just because it looks complicated, don't overthink it. It's just keep the top, change to multiplication, flip the bottom.